Imagine gaining the ability to see in total darkness. Or even through your own eyelids, just by popping in a contact lens. Sounds like pure science fiction, right? Like a superpower straight out of a comic book. But today, we're diving into a scientific breakthrough that, well, it makes this once futuristic idea feel pretty real. We're talking about new supervision contact lenses. These things allow humans to perceive infrared light, a spectrum usually totally invisible to us.
Yeah, it's pretty wild stuff. And our mission for this deep dive is really to unpack the incredible engineering behind these lenses. We want to explore their, let's say, profound potential to fundamentally redefine how we see, how we interact with the world, and consider what this all means for our future. It's all based on some truly fascinating research coming out of the University of Science and Technology of China, published recently in Cell Press.
Okay, so let's set the stage for everyone listening. Really basic question, but key.
Right.
Why can't humans naturally see in the dark, and what have we been relying on up till now? Feels like we've been stuck with this limitation forever.
That's a perfect starting point, actually. It really highlights why this new tech is, well, potentially so huge. As humans, our eyes are amazing, truly complex, but they're only built for a tiny, tiny slice of the electromagnetic spectrum. We call it visible light, right? Roughly 400 to 700 nanometers, violet to red. Anything outside that. UV light below 400, infrared light above 700, it just doesn't register. Our receptors can't pick it up. And for night vision, we're really talking near infrared, usually in that 800 to 1600 nanometer range. It's right there, but invisible to us. So yeah, for decades, if we wanted to see infrared, we needed external stuff, often bulky technology. Think about those classic night vision goggles. From World War II onwards, they were game changers back then. But the principle was fairly straightforward. An electronic tube grabs faint visible light or near-infrared photons, little light packets, turns them into electrons. Those electrons then hit a phosphor screen, making it glow that sort of iconic green, making the invisible. Visible, basically.
Right, that classic green glow. Everyone knows it from movies.
Yeah.
But yeah, they look heavy, awkward. What were the main problems? Why weren't they practical for, everyday people?
Exactly. Revolutionary for their time, sure, but big drawbacks. The most obvious. They always needed power. That meant bulky batteries. You were kind of tethered, cumbersome. Definitely not something you just wear around casually. Imagine trying to jog at night with those things strapped on. Not happening. And beyond that, they weren't very precise. They couldn't really tell the difference between different types of infrared light, especially the longer wavelengths.
Ah, okay. So it was more like a general light on, light off signal in that green haze, not like seeing details in the infrared.
Pretty much. You couldn't tell, say, this specific infrared signature is a warm body, and that one is a hot engine emitting at a different wavelength. It was just a blurry single color view, not precise.
Got it. A general enhancement, not a true expansion of vision.
Exactly. And for a long time, that was the best we could do. But what if? What if all those limitations just vanished?
And that's where it gets really interesting. Imagine all that capability, maybe even better than the green glow, like a detailed view shrunk down.
Yeah.
Shrunk down to something that fits on your fingertip. That's the promise here. These new contact lenses. Non-invasive, no power source needed, and letting you see both infrared and normal visible light at the same time. It's like unlocking a whole new sense.
It really is. Which brings us straight to the big question.
Yeah.
How exactly do these supervision contact lenses grant us infrared sight, especially without batteries or bulky gear? It sounds almost like magic.
Ah, yeah, it does feel a bit like that, but it's just really clever science. The core tech. It involves something called up-conversion nanoparticles. Okay, don't let the name scare you. They're basically microscopic, specially engineered crystals.
Yeah.
Often made from rare earth minerals, things like sodium, gadolinium, fluoride, but then they embed them with other elements like ytterbium, erbium, even gold sometimes. Think of them like tiny, highly specialized light transformers.
Transformers, okay. And the key is how they're tuned. The researchers figured out how to make these specific combinations absorb one kind of invisible light and then emit it as a very specific visible color that our eyes can naturally see. And these little powerhouses, they're mixed right into the flexible, non-toxic polymer material. It's basically the same stuff as regular soft contacts.
Ah, so it's in the lens material itself, not just a coating. That makes sense for transparency. So infrared hits these tiny transformers, and then what?
Exactly. When infrared light, again, in that 800 to 1600 nanometer range, hits these nanoparticles, they soak up that low-frequency invisible energy. But instead of just stopping, they up-convert it. They re-emit that energy as visible light, like, say, green light around 550 nanometers, or blue or red, depending on the nanoparticle mix. Light our eyes are designed to see, so it's a direct conversion. Invisible infrared becomes visible light, right there on your eye.
That is, wow. Okay, so the advantages are huge. No power source, that's massive. And seeing both visible and infrared at once, because they're clear. But what about that claim? Seeing better with your eyes closed. That just sounds wrong. Why close your eyes?
It does sound counterintuitive, doesn't it? But it's one of the most fascinating parts, honestly. And maybe one with the biggest implications. You're right. The battery-free thing, the simultaneous vision, those are huge leaps. Now, seeing with eyes closed, the researchers specifically found wearers could perceive the infrared signals more effectively that way.
How?
It's physics, really, and biology. Near-infrared light just happens to penetrate skin, like your eyelid, much better than visible light does. So when your eyes are open, all the normal visible light around you creates a lot of visual noise, interference. Makes it harder to pick out subtle infrared stuff. But close your eyes. You block out most of that visible light noise. Suddenly, the infrared signals stand out much more clearly, like trying to hear a whisper in a quiet room versus a loud one. It gives you this almost unimpeded, focused infrared view.
That's incredible. It really shifts things from needing a device on your head to having the sense within your eye, almost. Okay, so the crucial next question. Have these things actually been tested on living beings? What were the results? Was it safe?
Absolutely. Safety and, does it actually work? Paramount questions. Before humans, they did rigorous tests on mice. They actually carefully sutured these tiny lenses onto the mice's eyes for stability, continuous exposure, and the results. Pretty compelling. The mice with the lenses showed clear behavioral signs they could see infrared. For example, they actively avoided boxes lit only by infrared light. They preferred totally dark boxes, which makes sense, right?
Oh.
Mice are crepuscular, they like the dark, so they were clearly seeing the infrared as light to avoid.
Okay, so behavior changed, but physiologically. Did their eyes react? Did their brains register it?
Great question. Yes. Beyond just behavior, there were clear physiological signals too. The pupils of the mice wearing the lenses. They actually constricted when exposed to infrared light. That wouldn't happen normally in the dark if they couldn't perceive light. And, crucially, brain scans showed their visual processing centers lighting up, firing in response to the infrared. Strong evidence their brains weren't just getting signals, but interpreting them. And maybe the most important bit for the future. The lenses proved to be completely non-toxic, safe for the eye, even over time.
Okay, non-toxic, safe. That's a huge hurdle cleared. But mice are one thing. What about people? Did humans put these in? How well could they see?
Right, the human trials. Equally impressive, maybe even more so in terms of precision. Human participants wearing the lenses could clearly see flickering infrared light, no question. But more than that, they could accurately detect flashing signals, like Morse code, sent only using infrared, and they could tell the direction the infrared beams were coming from. So it's not just a vague glow, it's perceiving specific coded information. Pretty clearly, too.
Wow, Morse code. And direction finding. That's way beyond just basic see in the dark. And the lead researcher, Tian-Su, he confirmed the eyes closed thing too.
Yes, absolutely. Tian-Su, the senior author, was very clear. He basically said, and I'm paraphrasing slightly, it's totally clear-cut. Without the lenses, nothing. Put them on, they clearly see the flickering infrared.
Yeah.
And he specifically backed up the eyes closed benefit, saying they're even better able to receive this flickering information when they close their eyes. Because, again, near-infrared gets through the eyelid better, less interference from visible light. It's a really unique advantage. And check this out, another layer of cleverness. They didn't just stop at making infrared visible. They figured out a tweak to let the lenses tell the difference between different types of infrared light by color-coding them.
Wait, what? Color coding invisible light? How? How does that even work? And what good is that beyond night vision?
By slightly changing the recipe for those up-conversion nanoparticles, they could make specific infrared wavelengths show up as different visible colors. So, for example, maybe 980 nanometer infrared gets converted to blue light that you see. And maybe 808 nanometer infrared becomes green light, and 1532 becomes red. Now think about the implications. This goes way beyond just seeing heat in the dark. Imagine someone with common red-green color blindness. What if the red wavelength they struggle with could be converted by the lens into, say, a distinct blue they can easily see? It could potentially help them differentiate colors they couldn't before. It's not just adding night vision, it's potentially remapping their perception of the visible world, too.
That's genuinely amazing. Not just seeing more, but seeing differently in a way that could help people with existing vision issues. Okay, bigger picture then. What are the real-world applications and future implications here? This sounds like it could shake things up.
Oh, the practical benefits could be huge, really wide-ranging. First, enhanced safety. Think about pilots trying to land in thick fog or smoke, firefighters searching smoky buildings, first responders in pitch-black rescue situations. This kind of non-invasive, battery-free tech would be massively better than the bulky gear they use now. Imagine seeing heat signatures right through the smoke, just with your eyes.
Yeah, that's a game changer. And I guess with the flickering light communication, security, covert ops, seems obvious given how discreet it is.
Absolutely. Transmitting info with invisible, flickering infrared light. That opens up completely new possibilities. Secure communication that's basically invisible to anyone without the lenses. Anti-counterfeiting, maybe? Hidden infrared markers on products only visible to inspectors with the lenses. And yeah, the researchers themselves mentioned military applications and covert spy stuff. You can imagine scenarios where stealth and seeing the unseen would be critical. A contact lens is about as stealthy as it gets.
Okay, but let's temper the excitement a bit. This is still proof of concept, right? It works in the lab, but it's not like you can buy these tomorrow. What are the current hurdles? Like, can they pick up faint heat signatures yet, or just bright lights?
That's exactly right. It's incredibly promising, but yeah, key limitations still exist. Right now, they really only work well detecting infrared from very bright sources, like powerful LEDs used in the lab tests. So a major focus now is boosting the sensitivity, making those nanoparticles much better at picking up lower levels of infrared light. That's what you'd need for real-world ambient conditions, seeing faint heat from a person or animal in total darkness, for instance. Another challenge, being right on the retina means sometimes detecting fine detail can be tricky. So for things needing super high resolution, they've actually also developed wearable glasses using the same nanoparticle tech, sort of a complementary approach. But the main goal is definitely collaboration, working with materials scientists, optics experts, pushing for better spatial resolution and higher sensitivity right in the lens itself. Make it clearer, more detailed, more practical.
Right. And you can easily see this merging with things like AR or VR down the road, can't you? Adding infrared data as another layer onto your vision, like a digital sixth sense. Okay, so let's wrap this up. To recap these contact lenses, revolutionary potential. Seeing in the dark without gear, maybe aiding color blindness, new communication channels. It's like having an optional superpower.
It really is.
Yeah.
It's a powerful glimpse into a future where maybe our basic human senses get fundamentally enhanced. Being able to perceive light that's always been invisible, that could change so much about daily life, safety, security, even medicine, really pushes the boundaries of what seeing even means.
So here's the thought to leave you with. If you could just slip in a lens and see everything in the dark, or decode hidden light signals, what does that actually mean for our world? What about privacy? How does it change our understanding of what's visible and what's hidden? Well, it's a lot to think about as this tech develops. We'd definitely love to hear what you think about this night vision tech. Or maybe other supervision ideas you find fascinating or maybe a little scary. Let us know.
Yeah, and maybe take a moment to consider how enhancing our basic senses like this could reshape things. Daily life, sure, but security, human potential.
Well,
it's pretty profound.
Thanks so much for joining us for this deep dive into the future of seeing. We'll catch you on the next one.